Well, you're not going to have that at home, no. Let's try this one together. Number 1. Let's look at this. Make it a little harder on you here. Yeah, go ahead and write it down. Give you a second. Although it would be nice if you had a PowerPoint.
Oh, forgot. So, I think he needs to provide a PowerPoint. It's kind of hard to go halfway where you're. I think I already know how to do this.
Okay. Looks complicated. Looks complicated. It's not really that bad. This time, I threw in a subtraction sign on you. In this problem down here, I threw in an addition, then another subtraction. All it does is divide it into 2 pieces. So literally, you can just divide it into 2 pieces. Think of it as 2 problems almost. So there's 2 problems here. One on the left side, one on the right side. Let's do the one on the left first. What do you think? Okay? Good. 7 times 2 is 14. That doesn't change. Numbers are numbers. Now we look at our bases. A and an A. What's A times A squared?
A to the third.
Good. We add the exponents. All right, so I'm done with the 7, done with the A, done with the 2, done with the A squared. So since there's only one B left, we just rewrite it. It's like saying B times 1. B times 1 is still B.
You can put 1 above the you can't for
An exponent, sure.
Yeah.
It's an understood
So
one.
you really don't
Yeah.
have to put it there.
Now we're going to rewrite the negative, the subtraction sign, and we're going to do this side. 5 times, what's over here? 1. There's an understood 1 right there. So 5 times 1 is 5. Okay? So done with the 5, done with the 1, if you want to write it. Now what? A to the third. A to the third stays the same because there's no A over here to multiply by. And then just B. All right, now to our next trick. Adding and subtracting with these bad boys. You have to follow one rule. The bases have to be exactly the same. When I say bases exactly the same, you need to look. I have an A here, right? What's the power on that A? 3. I have an A here. What's the power on it? To the third. Are they the same? Yes. I look at the B's. What's the power? It's a 1. What's the B here? 1. They are exactly the same. Every base is the same. That means rewrite the base, A to the third, B. Just write it once. And then you do normal subtraction. I hope you can do that. 14 minus 5 is 9. There's your answer. That's the answer. Let's try this one down here. It's another subtraction one. Not very many numbers here, so it looks confusing. Again, divide it into 2 problems. On this first problem, what do we get? Let's put it in alphabetical order. Now, that's a kind of a formality. So it would be A to the 2nd, Y to the 4th. Good. So that's that side. Minus. Oh, I'm sorry. What's wrong? He's always had a problem with that. Oh, let's put your head down a second so you can see. I know it's low on the board. Can you see now? All right. Oh, see, you don't have to fall asleep. I didn't mean that. Over here, what do? 2 and negative 3 is negative 6. A to the what? A to the 2nd. Good. That's 1 plus 1 is 2. And Y to the 1 plus 3 is 4. Now, negative, negative, no matter what, turns into a positive. So I'll turn that, change, into a positive. Now look at your bases. A squared, A squared. Y the 4th, Y the 4th. How about that? They're the same, aren't they? So, what is A squared Y the 4th, or look at it this way, 1A squared Y the 4th plus 6. The answer is 7A squared Y to the 4th. What do you think? Think you can handle that type of problem?
Yeah.
Spencer, were you able to see it? You know, down there at the bottom. I'm sorry about that. Yeah.
What if they aren't the same?
If they're not the same, that is your answer. If they're not the same, leave it alone. You have to have like bases to add or subtract. Matt, you got questions?
Yes, later.
Good? Okay. Let's move on to rule number 2 for the day once I get through these steps and answers. There we go. Last one's there. Next rule, power to a power rule. Looks like this. We've got a power right here. In this case, it's A. It's raised to, what we call raised to, another power. The key here is the parentheses with the power on the outside of the parentheses. If this is the case, we no longer add the powers, we multiply. We multiply our power. Power to a power means multiply. So let's look at a number example. I think it'll make more sense to you. N to the third raised to the second power. N to the what? N to the sixth power. 2 times 3 is 6. That's about the most basic example I can give you. Obviously, they're going to get more complicated. If you did it the long way, we wrote it all out, n to the third squared means n times n times n, right? But what's a squared literally mean? There's 2 of them. There's 2 of them. Squared means there's 2. So if we wrote it out the long way, now this is the long way, which you should probably will never ever do, but just to give you a visual representation, if there's 2 of these, here they are, for a total of how many n's? If you added those up, you'd get n to the 6th. Well, the power rule makes it that much easier. We don't have to do all that work, and we get the same answer. That's why we do these rules, because we don't want to spend all that time writing out n's for the rest of our lives. Let's try 2 and 3. See if you can get them. Use that power to a power rule. Power to a power. What's that, bud?